2.1, the distance and midpoint formula. So these are formulas and concepts that you already have seen or are supposed to know about. Now we're just going to build upon these ideas that you've seen already, like the distance formula and the midpoint formula. So let's talk about the distance formula. It's d for distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So we group our x's, we group our y's in order. And in our midpoint formula, your midpoint is a point on the graph, that's why it's xy. To find your x, you take both of your x's and divide by 2. To find your y, you take both of your y's and you divide by 2. And you're going to find the middle point of the segment or line, whatever you're trying to find. Let's practice using the distance formula. Let's find the distance between the points 4, -3, and 2, 5. So anytime we're going to be using a formula, we should always write it out, because the more you write it out, the easier you're going to have. You're going to have it in your back pocket. You'll know it. So let's write it. And we know to use the distance formula because it says find the distance. So we need to find the distance. And that's distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Alright, so mostly from here on out in your math classes, it's going to be formula based. A lot of formulas you're going to learn and use. So what I love about a formula, when you do a little resume on Microsoft Office, you're not actually doing a resume. You're filling out a template. It's not like you're starting at a blank page, right? Most of us, we download the template and then we fill it out, right? That's how I know how to do a resume. I don't really know how to do a resume other than that. And that's all this is. A formula is a template. So we're going to write out the template and fill it in as we go. And it makes our life a little easier. Just trust me. These little things are going to help you be successful in this class and every class from here on out. So our template is the square root of parentheses blank minus blank squared plus blank minus blank squared. So what we do is we fill out our template. And our x1, y1, x2, y2, they come from our points. Label your points. That's a great habit to get into. I know you're like, I can see them. I don't need to label them. When I teach trig, I see a lot of people mess up because they put the wrong points in the wrong places. Label your points. So we have x1, y1, x2, y2. Now let's fill it in. We have x2. x2 is represented by 2 minus x1. x1 is represented by 4. And then that's squared. We're going to add that to y2. y2 is represented by 5 minus y1. And y1 represents -3. Remember, if it's a negative, we always wrap it. Okay, we can clean this up. Minus, minus, we know that's going to turn to plus, plus. And let's simplify. 2 minus 4, that's -2. So we have -2 squared plus, and then now we have 5 plus 3, that's 8. So we have 8 squared. Alright, -2 squared, that's 4. Positive 8 squared, that's 64. 64 and 4, we get the square root of 68. Now, we can simplify this. You must simplify every single time. We're never going to tell you to just start simplifying. That's something you're always just going to know you have to do. At the end of it, you must simplify. Now, what does that mean? Well, 68 can actually be broken down into the square root of 4 times the square root of 17. So I can simplify the square root of 4. The square root of 4, we get 2. The square root of 17, we can't do anything with that. So this is our distance. Our distance is 2 times the square root of 17 units. We say units because it's a distance, but if you forget that little part, that's okay. Example 2. Let's consider the 3 points. A, -2, 1, B, 2, 3, C, 3, 1. We're going to plot each point and form the triangle. I know it's a triangle because it's A, B, C, that's 3 points. Find the length of each side of the triangle. Verify that the triangle is the right triangle. Find the area of the triangle. And the little white text, we'll talk about that after we finish A, B, C, D. Alright, so it says let's plot each point and form the triangle. So if we look at our points, we have -2, 1, 2, 3, 3, 1. My x's go from -2 to 3, and my y's go from 1 to 3. So I don't need, please don't draw this, I don't need a giant coordinate plane because it only goes from -2 to 3 and 1 to 3. I only need a little pieces. I only need a little bit. Draw what you need. That's actually something I'm trying to teach you. We're only going to draw what we need. That's actually a big deal in trigonometry and calculus. Only draw what you need. So for my x's, it goes from -2 to 3. So here's -2. Here's 3. For my y's, it goes from +1 to +3. So there's 1, 2, 3. We drew what we needed. You don't have to, but it actually is super helpful, and you're just going to end up having to do it in trigonometry anyways, so let's get used to drawing for what we only need. Let's plot our points. We have A at -2, 1, so that's here. We have B at 2, 3, so that's there. And then we have C at 3, 1, and that's there. Let's go ahead and connect our dots as best as you can. Doesn't have to be perfect, just as best as you can. And there's our triangle. Alright, sweet. Let's do part B. So part B says to find the length of each side of the triangle. So what is that actually asking? I'll tell you. So if we just, please don't draw this unless you have a tablet because I can erase. It wants us to find A to B, B to C, and A to C. So it wants us to find a distance from A to B, distance from B to C, and distance from A to C. So finding the length is actually saying to find the distance. You want to find the distance between each of the points. Alright, so again, let's just make it known what we need. So we need to find segment A to B. We need to find segment B to C. And we need to find segment A to C. C to A, you could also say C to A. It does not matter. But let's say A to C because alphabetical order, it just looks better. And finding the segment is just saying find the distance between the points. So let's find the distance between every single one of these points. As always, though, we're going to fill out a template. So blank minus blank squared plus blank minus blank squared. All right, so for A to B, we're looking at points A and points B. So for A, B, we have x2. x2 is represented by +2, minus x1, which is represented by -2. And then we have y2 minus y1, so 3 minus 1. All right, let's clean this up because we know that's going to turn to plus plus. So we have 2 plus 2 is 4. So we have 4 squared plus 3 minus 1, that's 2. So 2 squared. Let's keep simplifying. 4 squared is 16. 2 squared is 4. 16 plus 4, we get 20, and we can simplify 20 because 20 simplifies down into the square root of 4 times the square root of 5. This is called simplifying radicals. If you need help on it, just look up a YouTube video, Simplifying Radicals. The square root of 4 is 2. The square root of 5 does not exist. So the distance between A and B is 2 square root of 5 units. And we're just going to do that again for BC and ANC. If you feel like you got it, pause the video, do BC, do AC. If you feel like you need another example, let's keep going. Let's do BC. Alright, so BC, we're finding the distance. That means let's fill out our template. So we have blank minus blank squared plus blank minus blank squared. Let's fill in that template with B and C. So x2 for B, we get 3. For C, we get 3. For B, we get 2. Y2 for C is 1. And Y1 for B is 3. Alright, let's simplify. So 3 minus 2 is 1. so we have 1 squared. 1 minus 3 is negative 2, so that's negative 2 squared. 1 squared is 1. Negative 2 squared is 4. We add those together to get square root of 5. We do not simplify because 5 is prime. You can't break 5 down into a perfect square, so we just keep going with our lives. Alright, last but not least, we have a to c. So a to c, let's create our template. We have the square root of blank minus blank squared plus blank minus blank squared. For a to c, so for c, our first x is going to be 3. For a, our x is going to be negative 2. Our y for c is 1. Our y for a is 1. Let's simplify. So minus, minus, we know this turns into plus, plus. 3 plus 2 is 5. So we have 5 squared. 1 minus 1 is 0, so we have 0 squared. We can just ignore that. 5 squared is 25. The square root of 25 is just 5. Alright, we have all of our lengths of each side. So that is just part B, finding the lengths of each side. Now we need to verify that this is a right triangle. So verify, that might be a new word to us in math class. So verify, you're going to see that especially in trigonometry and calculus. Verify means to show with work, a theorem, a rule, anything, a postulate, just showing using stuff in math that something is true. So what we're trying to do is verify that this is a right triangle. So we're trying to prove using math, using rules, using theorems that this is a right triangle. As of right now, the only thing, unless you've taken trigonometry in high school, but if you did, just ignore it right now. So right now, the only thing you know about triangles, it's a famous theorem, the Pythagorean theorem. We know for right triangles that the Pythagorean theorem can be used to prove it, which is a squared plus b squared equals c squared. However, what does a, b, c actually mean? Well, a stands for a leg, b stands for a leg, and c stands for the hypotenuse. The most important thing about the Pythagorean theorem is the hypotenuse, because the other two are just going to be legs. So what you do first is you find the hypotenuse. The hypotenuse is the largest side, longest side, biggest side, however you want to say it. It's the side with the most value to it. So let's go back to our lengths of the side. You see why we had to find the lengths of each side? Because we need to know what is the hypotenuse, what are the legs. So you go back to before we simplified. So right when it was actually a square root. Let's look at each of them when they're square roots. So if we look, we have 5, 25, and 20. 25 is the biggest number. That means the hypotenuse is actually AC. The other two are legs. So after you find the hypotenuse, which is AC, because that's the biggest number under the radical, the other two are going to be your legs. It doesn't matter which one is which. The other two are your legs. So the other two, we have the square root of 5, which is BC. And then we have square root of 20, which is represented by AB. Let's fill it in. For BC, we know that's the square root of 5 squared. For AB, that's the square root of 20 squared. And then our hypotenuse, we know that's the square root of 25. And we're squaring it. We square it because that's the formula. So this is same power, same index rule. Because remember, there's a little 2 here. There's always a little 2 here. We just don't write it. So you see how there's a little 2 and a little 2? That's called same power, same index rule. They actually just cancel each other out. So we have now 5 plus 20 equals 25. 25 does equal 25. So there is no answer like yes, no. The work is your answer. So this right here, that's going to be your answer. You don't need to box it. I'll just look at your work. But that's how you verify that this is a right triangle, because the Pythagorean theorem states if you square your legs, it will always equal the hypotenuse squared. That's where we're going back up to here. The sum of the squares of the lengths of the legs of the triangle is blank. The square length of the hypotenuse of the triangle is blank. So what this is actually asking, the top one, when you squared your legs, what did you get? When we squared our legs, we got 25. Alright, now, the square of the length of the hypotenuse of the triangle, that's when we squared the hypotenuse. When we squared the hypotenuse, we got 25. Because those are the same numbers, we know that for sure this is 100% without a doubt a right triangle. You have to show using work. Part A, that doesn't tell me it's a right triangle. So don't just draw a triangle and say, yes, it's right. Because what if that's 90.1 or 89.99? You don't know. Never assume in math. Ever. You can never assume anything in math. We have to prove it. That's why it's important that we have laws and postulates and theorems. So we can prove using math in part C, yep, for sure, this is a right triangle using the Pythagorean theorem. I want to blow your minds for a second about Pythagoras. I'm sure you've seen pictures of this person, a Greek person who lived on an island in southern Greece. However, Pythagoras never existed. Google it. Google, did Pythagoras ever exist? He didn't. Dude is completely made up. I'm not even kidding. I take history of math classes. I've read history of books of math and stuff like that. Pythagoras never existed. You've been lied to your whole life. Interesting, right? Alrighty. Let's talk about part D. Part D says to find the area of the triangle. Alright, so area of a triangle is 1/2 base times height. Have you ever wondered why that's the formula? I did. I always did. I'm going to tell you why. This is a rectangle. An area of a rectangle is base times height. We know that. Length times width, x times y, it all means the same thing. However, if I do that, don't we have a right triangle? And isn't it half of a rectangle? That's why area is half base times height. Okay, your base and your height, that's actually pretty easy. They are your legs. Your legs are your base and your height. And you already know your legs. We found them. Part C led us to that. So we already know our legs. Let's plug it in. We have 1/2 blank blank. Our first leg was represented by the square root of 5. Our second leg is square root of 20. Remember, we always multiply our things that look alike. So we're going to multiply our square roots first. 5 times 20, that's the square root of 100. The square root of 100 is 10. And half of 10 is 5. So our area is 5 units squared. Example 3. If 4, -2 is the endpoint of a line, and -9, -1 is its midpoint, find the other endpoint. Alright, as always, I like to draw stuff out. It really helps clear things up, because that's something that you actually have to do in trigonometry, which for most of us is going to be the next class. So let's get used to drawing now, since we know it's something that you're going to have to do, and it's actually a standard of trigonometries to draw the things you're working with. So let's start practicing when it's a little easier, a little more approachable. Alright, so we have 4, -2, -9, -1. So those are the only points I have. Let's go ahead and draw them. Alright, so we have 4, -2. So 4, -2 we go right 4 down 2. So it's about here. That's where 4, -2 is going to be. Somewhere in this region. And then we have -9, -1. So -9, -1, we can say is like somewhere right here. It's about there. It's going to be somewhere right there. So now it's actually asking, where's the other endpoint? So it wants us to find the other endpoint. So hypothetically, the other endpoint should be somewhere right here, right? It should be somewhere in that area. So the midpoint is equidistance from opposite ends. So meaning that's in the middle. So if that's in the middle, we can actually just count our distances to figure out how much do we need to go. So from here to here, my x's. So from here to here, use your fingers. 4, 3, 2, 1, 0, -1, -2, -3, -4, -5, -6, -7, -8, -9. That's 13 in the negative direction. So to get from 4 to -9, we minus 13. That means we do the same. So if this is minus 13, that means from here to here is going to be minus 13. So -9 minus 13, we get -22. That's our x. Now we do the same thing but with our y's. So for our y distance, we go from -2 to -1. So from here to here, we actually plus 1. That means from here to here is going to be plus 1. So -1 plus 1, we get 0. That means the endpoint is -22, 0. And that supports where it should be. Let's find the midpoint of the line segment from P1, -5, 5 to P2, 3, 1. So now we're finding the midpoint. The midpoint, that's a formula. Midpoint equals x1 plus x2 over 2, and then y1 plus y2 over 2. All right, our x1, y1, x2, y2, they come from the point. So we have x1, y1, x2, y2. All right, as always, because we're filling out a formula, let's just create the template. So blank minus blank over 2, blank plus blank over 2, and blank plus blank over 2. Our x's, our x1 is -5. Our x2 is 3. Our y1 is +5. Our y2 is +1. And that's over 2. All right, let's simplify. -5 plus 3, we get -2 over 2. 5 plus 1 is 6, so 6 over 2. Let's keep simplifying because -2 over 2 is -1. 6 over 2 is 3. So in the middle of those 2 points is perfectly -3, 1. Example 5. A car and a truck leave an intersection at the same time. The car heads east at 30 miles per hour while the truck heads south at 40 miles per hour. Find an expression for the distance apart d in miles at the end of t hours. So guess what again? We're going to start drawing. So we have a truck and a car leave an intersection. We're driving east and south. There's directions. So we're actually going to draw a coordinate plane. A coordinate plane, those are just directions. That's never eat soggy waffles. North, east, south, west. Never eat soggy waffles. All right, let's draw what we have. We have a car. and it goes east. So this is the intersection. The origin, that's actually the intersection. So we have a car and it goes this way for some time. I don't know how long it goes. So it goes this way, it's going that way. Let's say we're here now. We drove some time and we're here now. So if that were a point, we don't know the numbers, but we can think of a point. Because that's on the x number line, it doesn't go up or down. So our y is 0. And it went some type of distance. So distance 1. Then we have a truck head south at 40 miles per hour. So south is this way, down. It's going, and let's say now it's here. So that point, I didn't go left or right any. So the x is 0. However, we went down on the y-axis. So that's going to be a negative distance. And we say distance 2 because we have the car distance and we have the truck distance. What it's actually asking us to find is to find a formula, an expression from here to here. That's what it's actually asking us to find. So let's start pulling out some details. The car. We know the car, we said that's going to be distance 1. And that goes 30 miles per hour. Miles per hour is actually a distance because it tells you how many miles you went per hour. So if you're doing 30 miles per hour, you're going 30 miles every hour. And we just said that's a unit of time. So 30 miles per hour is actually 30 t. Then after we drew it, we came up with the point D1, 0. Well, we know what D1 stands for now. D1 stands for 30t. Because however long you're going, you multiply it by 30 and then you get how far you've went. Now let's do our truck. So our truck, we said that's distance 2 because it's a second time. It's a second thing we're talking about. And we're saying that it's going 40 miles per hour. We know miles per hour now, that's a unit of time, so 40t. We came up with the point of 0, negative d2. It's negative because it went down. South is down. So we have 0, negative 40t. And if it wants us to find the distance, it's telling us to bust out the distance formula. And you know where our x2, y2, x2, x1, y2, y1 come from? They're coming from the points we actually just created. Okay, let's plug them in. So we have x2, which represents 0. x1, which represents 30t. And then we have y2, which represents negative 40t. And then we have y1, which represents 0. Alright, let's simplify. Let's take the zeros out because we don't need them anymore. So let's just simplify. We'll technically have negative 30t, and we're going to square that. And we have plus negative 40t, and we're going to square that. So when we square, remember it goes to both things. Math is fair. Negative 30 squared is positive 900. T squared, that's actually just t squared. Negative 40 squared is positive 1600. T squared, that's just t squared. We can add those because they're both t squareds. So we have 2500 t squared. The square root of 2500 is 50. The square root of t squared is just t. So that is our distance over time. distance of time is 50t. So what we can do is, let's say they both travel for 4 hours, we can plug it in there and then we'll figure out how far diagonally they're actually apart. The reason why we had to do this d of t, because it says d of t. That's why we had to write that.